Greeting learners, so we're gonna continue with our session. Remember last time we stopped at question 6 to 1. Now we're gonna take question 6 to 2. 6 to 2, Kunda will buy a laptop that costs 20,000 Rand. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th February 2019. He will make his 60th monthly deposit on the 31st January 2024. The saving account pays interest at 8.7% per annum compounded monthly. Calculate Kunda's monthly deposit into his account. So if you can see, try to understand this question. They are saying deposit into a saving account on the 28th February 2019 and will make his 60th monthly deposit on the 21st January 2024, 5 years later. So here I see I'm going to use the future value formula. Let's go to solution. Future value formula, f is equal to x, 1 plus I to the power of n minus 1 over I. So as you can see here, the value of f is given 20,000. 20,000 will be equal to x, 1 plus, here we have got the interest rate was given 8.7, so it's going to be 8.7 divided by 100 and divided by 12 if it's monthly. So it will be 8.7 over 1,200. 60th monthly deposit to the power of 60 minus 1 over 8.7 over 1,200. So here we're just gonna use our calculator. Our I is down here. It's our formula is over I here over I. So let me take the calculator. 20,000 multiplied by 8.7 over 1,200, then we're getting 145. So we'll be having, let me use this space here for the rest of our calculation. I'm gonna use this space. We'll be having x times 1 plus 8.7 over 1,200 to the power 60 minus 1. This will be equal to 145. So the value of x will be 145 over this value here. Then we'll get the value of x. Let's use a calculator. 145 divided by this. We will be having divided by 1 plus 8.7 over 1,200. This to the power 60 to the power 60 come down minus 1 close bracket. Then we get, yeah, so the answer is 267.26 rand. Yeah, so we mustn't forget the currency x x is equal to 267,26. So we are done with question 6 to 2. I'm gonna clean the board, then we will go to the next question. That is going to be 6. If I read the question, is 6.3. Take the next question. We're done with the previous. It was 6 to 2. Now is 6.3. You know, win the jackpot of 1,600,000. You invest all of his winnings in a fund that earns interest at 11.2% per annum, compounded monthly. He withdraws 20,000 rand from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. So how many withdrawals of 20,000 rand will Tino be able to make from this fund? As we can see, this case is a case of a present value formula. So we're going to take our solution here. P is equal to x 1 minus 1 plus I to the power of negative n over I. So this is the formula for present value. The present value is given here as 1,600,000. This will be equal to x. The value of x also given is this 20,000. You withdraw 20,000 from the fund at the end of each month. So it's going to be 20,000 multiplied by 1 minus 1 plus I. We know the value of I. It was given. It's given here as 11,2. So we're going to write here, divide by 100, it's going to be 0,112 over 12 to the power of negative 1. And this will be over 0,112 over 12. So we will take it from here now, doing our calculations. What are we going to have here? We'll be having, I'm going to do the calculation here, and we're just going to remain with the value in the square bracket, and this will allow us to get the value of n. So I'm doing the calculations now. 1,600,000 multiplied by 0,112 over 12, and this will give me this value, divide by 20,000. Then I'm getting 56 over 75. Yeah, 56 over 75 here. This is the value I'm getting, and this will be equal to this square bracket. I can already claim here. I've done this 1,600,000 times 0,112 over 12 divided by 20,000. So this is the answer I'm getting here. I will be cleaning this to have space here down so that we can have some space here. Then we're going to get here 1 minus 1 plus 0,112 over 12 to the power of negative 1. Yeah. So I think from here, we're not going to maybe need the question. The question here was how many withdrawals of 20,000 will Tino be able to make from this fund? So this is the value of n we're trying to get here. So I'm going to clean the board here at the top to continue my calculation. We need some space here. And then I'm going to take this from here. We'll be having 56 over 75 minus 1. And this will be equal to minus 1 plus 0,112 over 12 to the power of negative n. So let's take the value of this on the left. What are we going to have there? 56 over 75 minus 1. We get in here negative 19 over 75, and this is going to be equal to negative 1 plus 0,112 over 12 to the power of negative n. As we can see, we're having negative both sides here, so we can simplify by negative 1, and we're only going to remain with negative 19 over 75 is going to be equal to 1 plus 0,112 over 12 to the power of negative n. So now, to calculate the value of n, we're going to take logarithm. Let me clean. So we're going to take logarithm of these values. We'll be having a log 19 over 75 will be equal to negative n log f. And here I will calculate this value into bracket, so that is going to be easy. The value into bracket, what are we going to get there? 1 plus 0,112 over 12. Then I'm getting 7. The value in the bracket here is 757 over 750. Now, negative n, here negative n will be equal to this value over this one. So this will be practically going to be the base of our log. So we'll be having log 19 over 75 to the base of 757 over 750. So once we get this value, and then it's going to be easy to get the value of n. I'm trying to get this log of the base is 757 over 750, and then in bracket there we're going to have 19 over 75. And what are we getting there? Then we're getting negative 147. Negative 147, 797. I'm going to round it up to 2 decimal places. And then we can see that the value of n here, negative n, will be equal to negative 147,80. I'm going to clean a little bit down here for having some space here. So our n will be finally n will be equal to 147, because being a decimal number here, we are going to consider the decimal part, and we will say Tino will be able to make 147 withdrawal of 20,000. So this is going to be the number of withdrawal, 147. Now, practically the final answer. So we are done here. This is the number of withdrawal of 20,000 Tino will be able to make. We're done with this last question of financial. That was practically 6-3, the last question. We are done. We're gonna go to the next question. The next question will be 7. I'm going to clean the board and then I will be writing question 7. Okay, now we're taking question 7. 7.1. Determine the first derivative from first principles if f of x is equal to negative 4x squared. Remember here, from first principles, there is a formula here we need to apply, and that is going to be f prime of x will be equal to the limit h tends to 0 of x, f of x plus h minus f of x over h. This is what we are applying. So our f of x is here. This will be equal to the limit h tends to 0. Here it will be negative 4 x plus h squared. This is x plus h minus f of x. Here you must be very careful because our f of x is negative 4x squared over h. And what are we gonna get here? Here we're having a perfect square. We will be having, I'm gonna write here, somewhere here, x squared plus 2xh plus h squared. This is the development of this. So multiply by negative 4, it will be negative 4x squared negative 8xh minus 4h squared, and here we're going to get plus 4x squared over h. Negative 4x squared plus 4x squared will give us 0. This is going to be 0. And then in the next step, the limit of h tends to 0. It will be minus 8xh minus 4h squared over h. We're going to factorize h here at the top. The limit of h tends to 0. Negative 8x minus 4h over h, and we're going to cancel, simplify h, and then we're going to remain with the limit of h tends to 0, negative 8x minus 4h, and if we replace h by 0, our first derivative will be minus 8x. That's the answer for this question 7.1. We're going to take the next question, and that is going to be 7.2. I'll clean the board, then we'll take the next question. Okay, so the next question is 7.2. Determine 7.2.1 f prime of x if f of x is equal to 2x cubed minus 2x. So here there's a for formula for power. If I'm having x to the power m prime, it will be m x to the power m minus 1 times x prime. Here is the identical function. Derivative will be 1. So here 7 to 1, f of x is equal to 2x cubed minus 2x, and f prime of x will be equal to 6x squared minus 2. This is 7 to 1. Sorry. Oh yeah, I think so. And then we're gonna take the next one. The next one is a 7 to 2. The derivative of 7, the cube root of x squared plus 2x to the power negative 5. So I'm gonna write it down here. We're having 7 cube root of x squared plus 2x to the power negative 5. So here we'll be having this. This I can write this like this: 7 x to the power of 2 over 3 plus 2x to the power of negative 5. So here now we're gonna get the first derivative. If you want to get your first derivative, you're not going to write this operator dx. We will go straight to the answer here. 2 over 3 times 7, we're getting 14 over 3, x to the power of 2 over 3 minus 1, 2 over 3 minus 1. Then we're getting minus 1 over 3 to the power of minus 1 over 3. And here is going to be minus 10, x to the power minus 5 minus 1. We get minus 6. So here's for the second function, here's the derivative. Question 7 to 2. I'm going to clean the board and go to the next question. 7 to 1, 7 to 2. We are done here. So I'm cleaning the board to go to the next question. Let me see. Cleaning the board to go to the next question. The next question is 7-3. I'm gonna write it down. 7-3. Okay, here's question 7-3. Okay, we're going to question 8 now. Question 8. Given the function f of x is equal to negative x cubed plus 6x squared minus 9x plus 4, and this will be factorized like this, is equal to x minus 1 squared times minus x plus 4. First question, 8.1. Determine the coordinate of the turning point of these functions. So the first thing we're doing, we're gonna take the first derivative f of x is equal to negative x cubed plus 6x squared minus 9x plus 4. The first derivative f prime of x will be equal to negative 3x squared plus 12x minus 9. And we're going to equate this to 0. Then we'll be getting the critical value. So dividing by negative 3, when we're going to equate this to 0, we'll be having, let me write it first, 3x squared plus 12x minus 9 is equal to 0. Dividing by negative 3, we'll have x squared minus 4x plus 3 is equal to 0. And if we want to factorize this trinomial expression, we need to get two numbers. One's sum will be negative 4 and one's product will be 3. So it's going to be x times these numbers. The sum is negative 4 and the product is 3. Negative 3 and negative 1. Negative 3, negative 1, we're going to get negative 4. Negative 3 times negative 1, we're getting plus 3. So the value of x here will be 3, and the other one is going to be 1. And then we're going to go back to the original function. We'll get f of 3 here. It's going to be negative 3 cubed plus 6, 3 squared minus 9, 3 plus 4. And let's get a calculator. What are we going to get here? Negative 27 plus 54 minus 27 plus 4. Then we're getting 4. So f of 3 is equal to 4 here. Then we'll go for the next one. F of 1 will be minus 1 plus 6 minus 9 plus 4. What are we getting here? Minus 1 plus 6 minus 9 plus 4. Then we're getting 0. This one will give us 0 because it's a negative 10 plus 10. We're getting 0. So here we having practically the coordinate of the turning point. Coordinate of the turning point. The coordinate of the turning point. Going to be the first one is a 3, 4, and the other one is 1, 0. So we're done for this first question. Coordinate of the turning point are 3, 4, and 1, 0. So I'm gonna clean the board and then we'll go to the next question. That is going to be question 8.2. Okay, so we're going to question 8.2. Our function was given already, but this time around, if we factorize this, we're gonna have x minus 1 squared times minus x plus 4. We can get two values that will be practically called the x-intercept. X will be equal to 1 if we equate this to 0, and the other value will be x is equal to 4. So let's draw our graph. We're having already the coordinate of our turning point are here. So let's try and sketch our graph. 1, 2, 3. In here, down, we're also gonna have 4 like this. Trying to sketch a graph here. 1, 2, 3, or 4 there. So here's your x, and it's going to be a y. So here's 0, 1, 2, 3, 4, 1, 2, 3, 4. So as you can see, for this function, we'll be having critical value. X is going to be equal to 1. The other one, x will be equal to 4. So here's 1, 0 is here. The other one will be 4, 0 is there. Our turning point, we have got 1, 0 here. So this will be practically our minimum. And the maximum will be 3, 4, 3, 4. 3, 4. Let's consider it like this. 1, 2, 3. Yeah. 3, 4. Here's 3, 4. Okay. If x is equal to 1, y will be 0. We are here. And if x is equal to 0, we'll be having 1. If x is equal to 0, we're also going to get 4. Then we can see our graph will be like this. We'll be passing here. We'll be passing here. If x is equal to 0, we're going to get 25 squared. 4. Yeah. 1 times 4 is 4. Okay. So here will be our graph will be like this. Will be our graph. And then it's gonna pass it 4 here. And here it's going to be like this. Here's our graph. Practically you can see this will be a minimum and this will be a maximum. So we have got 2 turning points. 1, 0 is here. The other one is 3, 4 is here. So this is the sketch of our graph. We are practically done with this question. They're asking us to draw a sketch graph, clearly label all the intercepts. We have got 1, 2, 3. These are the intercepts with the axis. And the turning point is 1 here, the minimum and the maximum. So we're done with this question. We're going to go to the next one. Let me clean the board. Okay. The next question is H3. Use the graph to determine the values of k for which negative x cubed plus 6x squared minus 9x plus 3 is equal to k will have 3 real and equal roots. We're having our graph already. As you can see, we were having the minimum and the maximum. These were the turning point. If we observe very well our graph, the value of k for which this function will be equal to k, will have three real and an equal root. Is the value of k between the value of the turning point. So we're going to have our k will be between 0 and 4, or we can say k, the number of this interval. The value of k is between the y values of the turning point, if we watch very well our graph. So this was practically a simple question. We're going to go to the next one. I'm going to clean the board and then we'll go to question 8.4. Next question is going to be question 8.4. Question 8.4, I'm going to write it down. 8.4, the line g of x is equal to x plus b, the tangent to f at the point of inflection f determine the equation of g. Okay, so this question, they say the line g of x is equal to ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. So if we want to get the equation of g being the tangent of f, let's remind again the equation of f. We will need it, so I'm gonna write it down. F of x is equal to negative x cubed plus 6x squared minus 9x plus 4. So we're gonna remember we start by getting the first derivative. F prime of x is equal to negative 3x squared plus 12x minus 9. This is the first derivative. Now, to get the gradient of this tangent, we will go to the second derivative. F second of x will be equal to negative 6x plus 12. And we're going to equate this to 0 in order for us to get the value of x. Negative 6x plus 12 is equal to 0. Negative 6x will be equal to negative 12. And the value of x is going to be 2. Our x is equal to 2. Then we will get the gradient of this tangent. That will be m is equal to f prime of 2. We will come back here and replace x by 2 here to get the gradient. So we'll be having negative 3, 2 squared plus 12, 2 minus 9. How much are we going to get there? I'm going to use my calculator. So we'll be having -12 plus 24 minus 9, and the value is 3. Our gradient is going to be 3. And now I'm going to get the equation of the tangent. The gradient is 3. The value of x is 2. We will need to get the value of y. When we were replacing the value of y, we did get that it was 2. Now we're going to write our equation, and this tangent will pass, will be having gradient is going to be equal to 2, and x is going to be equal to 2. So we'll be having y minus 2 is equal to 3 times x minus 2. Y minus 2 is equal to 3x minus 6. Y will be equal to 3x minus 6 plus 2. Y is equal to 3x minus 4. So this is the equation of our tangent, and we can write that this is equal to g of x. So we're done. To get the value of y, we are replacing here x by 2, and then we will get y minus 2. The gradient is 3. It's equal to 3 times x minus 2, and we end up getting the equation of the tangent is 3x minus 4. Okay, so I think we're going to stop here, and we will continue next time with the last question. That is going to be question 9 and question 10 for paper 1. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you have learned something. Thank you. Bye. You can stop the video. Let's stop here because you are sleeping. Stop it.